Good morning, guys. Welcome to school. Today we're going to be talking about the difference between the average velocity and the instantaneous velocity in a calculus discussion. The main idea today is that the average corresponds with the slope of the secant line, and the instantaneous velocity corresponds with the slope of the tangent line, right? What is a secant line? It is a line that intercepts our function at 2 points, and the tangent line is a line that intersects a function at 1 point. Okay, so with that little bit of background, let's go ahead and look at some visuals so that we have a better understanding of what I'm talking about. All right, so what am I looking at here? I am looking at a graph of the path of a function, of the path of an object, I'm sorry. So in this case, let's say that our object is, for example, it could be a ball, or it can be a Dundee. Dundee is something that you need to Google. Or it could be something like just a rock. Okay. And so the path of this rock is being modeled by this function right here. So this function is nothing but the path or position of my object. Okay. And here I'm going to say that the y-axis is going to be the height, and the height is being measured in feet. And my x-axis is going to be my time, and it's going to be measured in seconds. All right. So when I want to find the average velocity, well, obviously I want the rate of change of the position, right? So the v average is going to be the change in, I guess, y over the change in x. Okay, and so we said that y was the height and x is the time. Okay, so we're going to go ahead and find the rate of change between those 2 points. And so, okay, let me go ahead and use another color. Let me use blue. Okay, so, okay. I find the slope, and the difference between 1.5 and 2.5 is just 1 second. Okay, and the difference between 140 and 108 is just 32 feet. Okay, so I say, okay, 32 feet over 1 second would give me the average velocity between those two times, and this is nothing but 32 feet per second, and that is the average velocity. It's just the rate of change between 2 points. Okay, and so now let me reference these expressions here, and also this formula for the slope. Okay, so a and f of a, that is just an ordered pair, and that is basically 0.1. Okay, and this is going to be a plus h is essentially 0.2. Okay, what is h? H is nothing but the difference between 0.1 and 2 in the x direction. Okay, so we're going to call that the step. Okay, so let's write it here. It is the step, and it is the change in x. Okay, so when you're finding the average velocity, the change in x has to be relatively big. And by relatively big, I mean like 1 or 2 or even 0.5. So the points have to be a distance they have to be far away from each other relatively. Okay, because we're looking at a secant line, and the secant has to touch the function at two different points. All right. With that said, let's jump right into the instantaneous velocity and see what is different about the instantaneous. Okay, so now you'll see that I'm looking at the same position. Okay, so it is the same position function, so position or path or whatever it is. Okay, and of course the same thing here. It is the height. So height, and here is the time, and our units are still the same, seconds and feet. Okay, but this time we said that I wonder why that's not writing, but anyway, that's feet. When we look at the instantaneous, we're choosing just one point. And the one point basically creates a line that is called the tangent line. And so the instantaneous velocity, it's nothing but the slope of the tangent line. So we're moving away from the secant. It is the slope of the tangent line. Okay, so how do I approximate the slope of the tangent line if it's just one point? And plus I need 2 points to create a slope, right? But how we're going to do that is we're just going to make 2 points, and they're going to be very, very close to each other in distance. Okay, so what could be our step here? Our step has to be very close to the other, so let's say that it's 0.001. Okay, so that relative distance from the 2 points is close to each other. Okay, so we're going to choose one of our points to be x equals 1 and another point to be x equals 1.001. Okay, so the distance from those two values is our step. And let's go ahead and label that. Okay, so now I need to find the value of the function at 1. And the value of the function at 1 is given here. So the value of f of 1 is going to be 80. And the value of the function at f of 1, let me erase that, rewrite it, at f of 1.001 is going to be 80.064. Okay, so now I'm going to approximate the slope of my tangent line by using 2 points that are infinitely close to each other. So let me see the change. We said it was the change in y over the change in x. Okay, so it is going to be 80.064 minus 80, okay, y2 minus y1 over 1.001, which is x2 minus 1. Okay, and this would give us a slope of 0.64 over 0.001. Okay, and this is feet and this is seconds, and so the slope of those 2 points is going to be 64 feet per second. Okay, notice how I am saying, okay, well, I took the slope between 2 points, but those 2 points are so close to each other that we can say that instead of 2 points, we're just going to say it's a tangent, okay? Because those points are so close, all right? The distance between them is just non-existent. So the instantaneous rate of change at 1 is going to be 64 feet per second. So all I'm saying is that to calculate the instantaneous rate of change, you just choose a step that is very, very close. So let me go ahead and write that on another page. Okay, so if you want the average velocity, then you're going to take the slope of the secant. Okay, so you need 2 points that are at a distance, that are at an adequate distance. Okay, and if you want the v instantaneous, the instantaneous velocity, then you need the slope of the tangent line. And how do we approximate the tangent line? You're going to basically choose 2 points that are very close to each other. And how do I know that? Well, you're going to choose a step that is approximately 0.01 or even smaller, so 0.001. Okay, So for example, say I wanted to know the average rate of change of my function at 1. The instantaneous rate of change of my function at 1. So my next point should be 1.001. Okay? And now I'm going to take the slope of those values. So it's going to be f of 1.001 minus f of 1 over the change in distance. So the change in distance is going to be 0.001. Okay? Hopefully this video helps you and it didn't confuse you that much, and hopefully you can complete your assignment and get 100. Until next time.